Hello, my name is Stephen Hilton. I am the head of solutions at Space and Time, and I'm going to do a session on the intersection of data within AI and Web3. So with that, let's jump into it. Again, my name is Stephen Hilton, head of solutions at Space and Time. I've been in crypto for 3 years professionally. I've been an advocate and an enthusiast for many years. Um, but I've had 10 years in managing solution engineering team, especially in data-driven technologies, particularly in big data, 20 years in big data and data management. So most of my career has been in the data field in various flavors of engineering, right? Um, Recently, I've flipped over to doing that in the Web3 space. But again, I've been kind of following the industry and we'll say an enthusiast for a long time. So that's kind of me. Um, and the topic here, exploring the intersection of data within AI and Web3. And so we're going to do this in a few different chunks. I'm going to start with just kind of putting together some thoughts on why I think data traverses Web3 and AI very neatly, how they kind of fit together. We'll look at how AI is empowering Web3, and particularly using space and time, and then turn around and look at how Web3 can empower AI. And then we'll do some lightweight coding at the end. So this will be kind of one part discussion and one part technical. So we'll say it's lightweight technical. So with that, let's jump into the first topic here, Web3 and AI. So I think a lot of people are starting to recognize how well Web3 and AI agents in particular fit together, particularly when you start looking at the pros and cons, and how much of this is driven by the different characteristics of the data behind these platforms. And so you can see on the left we have blockchain, on the right we have AI, and the pros and cons. And you'll notice the pros and cons are flipped, right? The things that blockchain and Web3 are very good at, such as being decentralized or giving user control over their own data. These are things that AI today struggle with, right? AI today is very centralized, and that means that the data is largely controlled by large tech corporations, right? The large tech giants. And so, if we're going to get to a world where AI is really integral to your day-to-day existence, that means you're exposing all of your data in kind of an uncontrolled way to large corporations. Not that we think corporations are inherently evil, but they have different motivations than maybe you do. On blockchain, on the pro side, free movement of value, and that the data is deterministic and publicly provable, right? Whereas the cons of AIs today is that the usage cost of AI and the movement of value is largely from the consumer of AI to, again, these tech giants because it's so centralized. The data where in blockchain it's deterministic, publicly provable, of course, in AI today it's obscured, requires trust. That's not necessarily a characteristic or a decision by these large corporations, but because they're corporations, they have certain regulatory statutes they have to follow, so they don't always have the option. In other words, you're not going to find Google simply publishing all its user data out on the web because that would be a gross misuse of their power. But nothing's perfect. Blockchain has a number of cons. And most of these kind of could be bundled up by saying it's just very complex. It has a long learning curve. It's unforgiving of mistakes. If you send money to an address that doesn't exist, it's just gone, right? There's no undo in this environment. And really what this means, it's just not really made for humans. Blockchain and Web3 uh, time and time again, you see very talented companies trying to wrap Web3 in a way that makes it more usable, more forgiving for the imperfections of humans. Whereas AI, this is where AI shines, right? This is exactly what AI was designed to do, was to make systems easy to use, make them self-managing, basically mimic human interaction. That's really the whole point of AI is to, oh, I shouldn't say the entire point, but one of the defining characteristics is to be able to go to an AI system and say, I would like a picture of a purple panda eating oatmeal. And just just describing what you want as if the AI agent was another human is typically enough to get what you want. So in other words, you're not programming anything, you're not drawing anything, you're not opening up other interfaces. The interface is a human interface, right? And so if we could take these to all of the pros that blockchain brings that really, very cleanly mitigate the cons of the AI agent, and likewise, all of the pros of AI can very neatly mitigate the cons of blockchain, right? We start seeing what the future actually might look like if you could bring these two things together, right? Like now we have pros like decentralized. Imagine if you, and by the way, there's lots of companies out there working towards decentralized AI, right? But imagine if you're going to have an AI buddy, an AI agent that's going to kind of follow you around digitally, and it kind of almost becomes it becomes a personal assistant, but potentially could even have a personality that you fine tune to suit your style, and it's going to collect all the information about you. You may not want all of that information being sent to a centralized corporation, but if you could send it to or have it operated by a decentralized collective of node operators, all of a sudden the incentive is different. The incentive to be honest, it's crypto economically secure, and oftentimes cryptographically secure at that. So, the future of Web3 plus AI, it's decentralized. That gives you more user control over your own data, allows the free movement of value, because imagine if you had an AI agent that you could give an allowance to, or you could give a budget to, and it could make purchases or sales on your behalf, right? Because there's no intermediary it has to contend with. And then also deterministic is probably a little, we're still talking generative AI, so deterministic, but what it did, the logs of what's going on are there, and it's publicly provable, right? It requires no trust from a private entity. You don't have to say, well, my AI bot did some data movement on my behalf or did some movement of value on my behalf, and I trust that it happened. You can always go back and verify that. Now, unlike the previous slide where there were pros and cons, we really get pros and more pros, because not only do we get all of those pros merged together with the synchronization of AI and Web3 data together, you get pros and you get more pros, right? Because now you get all of the ease of use, the self-management, right? Having AI agents operate independently, you just give them instructions and they know how to go operate in the sphere of Web3. Right. And so you can imagine AI agents acting as financial advisors or operational managers or technical development, a lot of work in the development space. But even things like domestic coordination, right? You could imagine you could have an AI that um, operates within your home, can do things like like take a photo of your pantry or of your refrigerator, determine what food you have, at what levels you have them, and then you just simply give this AI, this domestic AI, a budget for food and say, when I'm low on these certain items, uh, place an order with my local grocery delivery service, and the food just shows up. All of a sudden, you don't have to manage that. That doesn't, it doesn't exist today, but we're talking about parts of the future. So you can see where these two things really work well together, and where, where there's so much potential for merging these two, Web3 and AI, together. All right. And by the way, if you want to do a little extended learning, there's a couple podcast and YouTube channel here that I think are really good. The podcast goes into the combination of Web3 and AI very deeply. It's I don't want to say it's old. It's a year and some. I think it's a year and a half old. But the ideas that are in that are really great. And then I just thought this YouTube video was fun because it proves that, like, the first AI bot that got to be a crypto millionaire, right? So like these things are happening, and kind of the all of a sudden the surprising choices and conundrums that you have to deal with when you have an AI agent that owns $1 million worth of crypto. So anyway, some fun extra reading for this if you're into it. All right, with that, we're going to move on to the next section here, which is talking about how we can use AI to empower Web3. And in particular, we're going to look at the space and time natural language to SQL agent. This is how space and time, one of the ways space and time uses AI to help make Web3 easier to engage with. So actually, for this, I am going to flip over to a demo. So if you give me just a moment, let's jump over to space and time here, and we'll do a quick demo. Let's see here. There we go. I'm all logged in. So I should explain what space and time is. Space time is a decentralized data warehouse that has ZK tamper-proof queries. So what does that mean, ZK tamper-proof? ZK stands for zero knowledge, and tamper-proof just means the tables cannot be tampered with once they're loaded. And so you put those two things together, essentially, it allows space and time or allows users of space and time to query a data set. In fact, we'll jump over here and we'll just drop in this data set here and run this, and you can get the query result as well as a proof, and you can take that proof to a verifier who will verify it for you. It's a third party, so you can take it to any verifier in the world, and they can verify the proof, because essentially the ZK tamper proofing, it's math. Uh, it's the way that, for example, ZK Sync does its roll-up activities. It doesn't rely on being optimistic. It doesn't even necessarily need to rely on consensus, although I think it does. But it's ZK means that you can mathematically calculate the fact that the table and the query in spacetime has not been tampered with. So, what is that like? What's the practical application of that? Imagine that you have a smart contract and it's a DeFi, and you're going to accept a wallet and a token and an amount that the user wants to borrow, right? The requested amount. In that scenario, today, most DeFi, most smart contracts, they have a little bit of compute and a little bit of data, and they don't have access to the full history of the chain. And so what they do is they just treat all of their users identically. Everyone gets the same yield on that particular offer. What you could do is use space and time, or use your smart contract to query space and time, go over terabytes of data, uh, like for example, get the entire history of that wallet address and calculate, return how many times has it been liquidated, how many times has it repaid in full, how many times has it paid early, the behavior of that wallet and the characteristics of it, return that back to the smart contract, and then make an informed, intelligent, more sophisticated decision, right? You could, maybe you want to offer a good user a better yield. Maybe you want to just flat turn down a user who gets liquidated all the time, right? So you can start making those more sophisticated business decisions in smart contracts because you have access to all of the data. And by the way, Web 2, the enterprise world today, they make all of their decisions using big data, right? All of the decisions are in proper enterprises, they are data-driven decisions. They don't just offer you a mortgage on a house based on the fact that they set the rate at 7% and anyone who walks in the door gets 7% regardless of their history. They obviously, do a lot of work to determine what they think the credit worthiness is. Until Web3 catches up with its ability to make those kinds of decisions, the Web2 world is going to be very hesitant about adopting the technology because it becomes a step backwards for them. Space and time bridges that. It allows smart contracts and other DApp kind of systems to leverage a big data, a large data set in real time, very low latency, and interject that data result into a decentralized process. And because it's ZK proven, it maintains uh, the trust factor of a blockchain, right? It's a trustless system. You don't have to trust a blockchain because you can prove it. You don't have to trust a query from space and time because you can prove it. You just prove it with math instead. So that's kind of the high level space and time. We obviously index different blockchains into the system. I'm showing them up right here. These are, again, large tables. So this is a 400 gigabyte table. Um, where's our big one here? I think our log table is right here. That's 800 gigabytes, so it's encroaching on a terabyte. I think if we go to a higher volume chain, like maybe Polygon, yeah, so the logs table in Polygon's 4 terabytes, just that one table. And then the transactions, wherever it is half a terabyte. So you can start doing really big queries on blockchain data because we go from block 0 to about 10 seconds after block finality, in that ballpark. So, where does this intersect with AI? Let's run a query, and I'm going to just grab this one right here. This is going against Bitcoin transactions, and what we're doing is getting the date. We're going to look up and count the number of blocks and then count the number of transactions for the last 14 days. And we'll put it in order by 1. That'll order it by the block date here. In about 2.5 seconds, it traversed this transactions table, which is 1,000 gigabytes, otherwise known as a terabyte. So, you can see it's obviously a big data system. It's designed for traversing large amounts of data, pulling out information quickly. Cool. What if you don't know SQL, right? What if you said, neat, but I want to look up something on Aptos, right? I want to look up the ANS, the DNS, but the ANS on Aptos. Let's see if we could do that, but instead of writing SQL, we can just type in a natural language prompt. Show me how many distinct Aptos ANS domains exist that are still active by year and month. And I'm going to run this, and it's going to reach out to an LLM of choice, and it's going to have the LLM construct a query based on my question, just my natural language question. And you can see it's a little more vertical than I might otherwise write it, but it looks like it got it right. It's deleted false, so I asked for active. Year, month, and the count of active domains. So there they are. I didn't have to know anything about the Aptos data model. I didn't have to know even how to write queries. It's useful if I can look at it and determine, you know, whether it's doing what I thought it would do. But I don't, this is an example of AI making something that's otherwise a little complicated, right? Uh, Space and time, we try hard to make the models intuitive and easy to understand, right? But it's still, blockchain has some complex ideas. And so as long as you understand what the ANS is, you understand that it's like a DNS, but it's an Aptos name server, then then you can ask for it very easily. Uh, you could you could say all instead of active that are still active. I think if I just said how many exist, I can run this again, and I'm going to get SQL that looks similar. This is generative, and so if you notice, it took a different way to structure it this time, but the end result is the same. It took out the where criteria of having it not have been deleted. So it did exactly what it was supposed to do. So it's an example of where AI can take something that can be fairly complex, or at least intermediately complex. Both you have to know SQL, but you also have to understand the data model behind Aptos, and uh, and made it as easy as just saying, show me how many domains exist, right? By this time dimensionality. As long as you understand what that is, you're good. And this is just one example. We have other AI products that are going to be released in the near future, so I'd encourage you to check back often. And if you want to go play around, you're certainly welcome to. The URL here is app.spaceandtime.ai, and this will just bring you to the home page. You can sign up for a trial account. You just come here. You can either connect a wallet and then use your wallet to drive your user experience, or okay, go away there, or you can just sign up for a username, password, and it will ask you for an email just to confirm that, and then you're in. And then you'll be a trial user for a while. It'll give you a certain amount of queries for free, and then um, you can try it out. All right. With that little excursion into how space and time is using AI to help make Web3 easier to understand and easier to work with, let's jump back to our slides. All right, here we are back at the slideshow here. We just got done covering AI empowering Web3, in particular on space and time, our AI engine. And like I mentioned, lots of good things coming up. You're going to continue to see both space and time, but I think the entire industry lean into using AI to abstract away complexity, especially in the Web3 world. But let's talk about how Web3 can empower AI. And so, probably the first way that space and time, but I think I'm going to say Web3 more generically, is doing things like value empowered AI agents. When I say value, I mean like financial power, like having AI have the ability to earn and spend and move money on behalf of users. Okay. And there's like some obvious examples like trading bots. These things are being built today. I've not actually tried it, but it seems like a really interesting idea, right? It's almost like having a financial advisor, except that it's AI. And again, using something like space and time, where if you can see all of these indexer nodes down at the bottom are writing data into the AI, or sorry, the space and time chain or the space time network. And then from that issuing either optimistic queries or ZK proven queries. You can see where we're feeding the data from these different blockchains, which are in and of themselves financial systems, like they're distributed ledgers. and making that available for AI agents to consume very easily. Now you get kind of this flywheel of being able to have AI agents understand what's going on, take some action, make a purchase or make a trade that is then executed on chain, which then goes back up into space and time, which goes back to the AI, which then can reassess, make a change or a trade or purchase or sale, which then goes back on chain, and you just keep going round and round. Having these systems, having these comprehensive data systems in Web3 that can directly power AI is a very powerful idea. Business budgeting bots, so having basically an AI agent that's a financial manager for you for your business, or even for your home. Integrated domestic bot, I think I mentioned earlier, having essentially a manager for the components of your house or your apartment, right? Having something that again can evaluate the stock in of your food or of your dog food or of different components, or monitor how many streaming services you have, and you can do things like assign budgets to these different elements and have the AI come through and say, you sure you really should be ordering that DoorDash because that's going to put you over budget. And by the way, I went out and looked up. There's a sale, at your local pizza place. Maybe you want to go out for pizza instead of ordering DoorDash. I'm making things up, but it's the idea that you have an AI agent that's there that can help in the domestic setting as well, I think is sometimes overlooked. And I think that's going to be the bigger game changer. Trading and business and everyone who's kind of in the Web3 world, like we're all trying to strive to make this reality. We sometimes lose sight of the fact that this is potentially life changing for everybody, even if they don't realize it. So that's how we see space-time providing a data infrastructure to power AI agents that themselves can move around value. Let's talk about user control data. So user control data. It's another good place where space and time really stands out. Space and time has a component that's a blockchain. We also have a component that's like a DPIN. But with the ability to do these ZK proven query results means that we can do things where we can provide the answer to a question without giving the underlying data. However, we can give you a proof that that underlying data has not been tampered with. So this is like really interesting. I think it's a use case we'll see a lot more, sometimes confusing. So let's maybe do an example. Let's say that you have a service where I don't know, you're collecting users for, I don't know, some online service, doesn't even matter what. So you have this user information and you want to share certain elements with partners, right? But you don't want to you don't want to expose your customers' data. You want to be able to answer questions about your users, but not actually expose any more data than you need. So, for example, maybe a partner says, I need to know when there's a user, I have to confirm that they're over 18 years old because there's regulations in place and, that's a requirement. They can run a query against your user data in space and time that simply says if they're over 18, answer yes, otherwise answer no. Pretty straightforward. They can run that. They have no access to the underlying data. They only have access to that yes, no. But they also can ask for that ZK proof, and the proof itself proves the query and the underlying data without them having to see it. Again, this is ZK, zero knowledge. So they get the answer without seeing the data. So now you have a system where you could have a number of different entities that maybe are competitive, or they, for whatever regulatory reason, they cannot share data directly, but they can do things like cooperate and um, answer questions for each other. So, like, let's say you have a number of financial services, like SaaS services, and fraud is an issue in your area. You can't share data with each other. That wouldn't be appropriate. But what you can do is say, hey, I have this user doing this activity. Seems like fraud to me. You could ask a question of another one of your competitor entities and say, here's this behavior from this user. I think it's fraud. What do you think? And they could give you back a fraud score, right? Like that behavior to us appears to be fraudulent, right? And as long as there's an understanding that everybody's going to participate, but nobody can actually see the data, all you're doing are sharing answers, not data, but you're also getting proof that nobody's cheating, right? That when you're asking the question, that the data underpinning that answer has not been tampered with. So there's all sorts of interesting use cases. Um, and this also opens the door to say, uh, I'm going to put some data into space and time. I'm going to give access to an AI agent that's not under my direct control, and I'm going to allow that AI agent to ask questions and specific questions without giving them access to my direct data. Right? So those kinds of, I think that really opens the door again for being super particular about what information you're sharing. And then I mentioned earlier, smart contracts, right? Being able to do big data use cases in Web3, because the future of smart contracts really are in ZK coprocessors. The ability to have a data problem inside of a smart contract that would be massively inefficient to solve inside the framework of a smart contract within the context of that. But man, if you can push that out to a different data system whose entire context is solving that particular problem, whether it's a relational data platform like space and time, or a vector database, or an object store, or whatever it is, right? Uh, that becomes really powerful. So, I think ZK is I think I think at some point it will really become recognized as kind of the third leg in that stool of Web3, AI, and ZK. It's just it's a more complex idea, and I think it kind of breaks people's brains sometimes. But with that, let's talk about what might this look like. This is just kind of an example, right, using space and time. Let's assume that we had an AI marketing agent, AI agent whose whose goal is to do marketing and is tasked with achieving, like, let's say, n number of impressions across different social platforms, or or certain clicks to a particular site, or whatever the marketing target is. It's given that to achieve, and it's also given a budget and a deadline and access to a pool of users. Now, the users are the users are going to opt in with either their wallet or their DID, and they're going to be incentivized to participate. Right? And this is the win-win-win of this type of AI marketing, or this kind of Web3 concept of marketing, which is to say users are fully in control of their data. They are opting into marketing campaigns based on what they find interesting. What marketers get out of it, they get a highly engaged and self-selected audience. They're not, one of the big, I spent many years in digital marketing. One of the big struggles is finding the right target market for for your brand, or whatever your program, your campaign is trying to target. Um, Big money spent on big data trying to call out different clusters of users who fit different categories, right? Soccer moms, or dads over 50, or kids on TikTok or whatever. I guess it's not TikTok anymore, is it? Um, but here you have people who may fit in that or may not, but they've self-selected the interest. So maybe who you might normally market to soccer moms, maybe there's somebody who's an 80-year-old grandpa who really is into that particular segment, and you would never target that person otherwise, but they can self-select into these marketing programs. And because they're self-selecting, they're getting incentivized. So instead of marketers paying large tech firms to just blast out to the best guests of the target market, um, they're not paying the big tech firms. They're paying the participants directly. Now it's a small amount, but to say, hey, we're going to do a program where we want you to help us evaluate footwear because we know that you are a big fan of Nike and you've opted in because you like to collect shoes, right? And now we can deliver to you new marketing on new options in shoes, on a reoccurring basis. And this is where AI comes in because AI becomes the constant engagement between the brand and the audience, right? It's the thing that's curating the experience for the user who's opted in is being incentivized, and then the marketing team gets a very highly engaged audience out of it. So it becomes a very synergistic, can never say that word, a very collaborative environment between the three. So and when the user's done, the user can just go turn it off. They're like, I'm done with this. Um, I'm tired of shoes. I'm for whatever reason, right? Or probably a better example is you have a baby. All of a sudden, your spending habits just radically shift. But if you select out of the ones that you're no longer interested in and select into the ones that you are, because you're being incentivized to do that, it commercials and ads, they feel annoying only when they're not well targeted, and most of the time they're not well targeted. If all of the ads were perfectly targeted, they would not feel like ads, they would feel like reminders, right? Or you would thank them for what they're offering you. It's just the fact that today they're so poorly targeted because the user ultimately has no say in what they're being advertised to. So this is just one example. We've done a number of examples with domestic bots and trading bots and other budgeting bots. But this is where the data, the intersection of Web3, because Web3 is required to do this incentivization. Web3 is required, or space and time, something like space and time is required to not just have the on-chain data, which is going to be public, it's going to have the value transfer, but also that private and ZK protected data, right? And it's like the combination of those things which would make something like this use case really powerful. So I think we promised a little bit of coding. But before we jump over to that, I just wanted to kind of point out that, of course, you can go to our docs page, docs.spacetime.io, or you can go to our webpage, spacetime.io, and click over to the docs. We do have SDKs for Python, Go, Node.js. I think we have a TypeScript through a partner, CLI, JDBC if you want to go old school. The REST API, which is this entire reference right here. And then we also have GraphQL as well. So we have a good number of different interfaces that you can use. But if you want to just super easy get started, Python's easy because Python's easy. So in Python, we'll just write a super quick script here from space and time, import space and time. And actually, let's do space time and sxt table. We'll create a table here. And we'll just say sxt equals space and time. And we want to give it an environment, an env file, which has all of our secrets in it. So I'm just going to say env file path equals env. Perfect. You can see AI is helping me out already. It does like to suggest a lot of stuff that I don't need it to do right now. Let's do authenticate. So at this point, those 3 lines of code should allow us to, no, not password, just settle down. There we go. And we're just going to run this in debug mode. And what this should do, if I did this right, is connect to space and time. And authentication success, true. So with those 3 lines of code, and actually you don't even need the table yet, I just put that in there. We're able to authenticate. We'll run a query. We'll say sxt execute query, and let's say interesting, but no. Let's say select star from sxt demo.stocks. Let's do that. And what it will return, if we look at the IntelliSense here, it's actually going to return a tuple, and which is going to be, oops, which is going to be a Boolean flag, which is whether it was successful, and then the data. And so I'm actually going to just run this again, although it's actually going to re-authenticate. That's fine. And we can see the data now returned, the stock data, open, low, close, blah, 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 blah. And also it will return true because it was successful. And that way you could do things like if success, print data, something like that. Turn around and run that one more time. So you can see how like pretty straightforward and easy it is to get started with only a few lines of code of Python here. We'll do one other thing here, which is let's say my table equals space and time table. That's not at all what I wanted. Yeah, this AI, the AI I'm using here is Codium, by the way, which is kind of aggressive, but it's pretty good sometimes. Let's say that we're going to do an AI manager user opt-in. So we're going to create the use case we kind of talked about in the last section where we're going to have an AI marketing, I said manager, AI marketing, and then you can go in and say, here's my wallet, I want to opt into this marketing program. This would be one of many tables that you would need to do this, but let's just create one table just for fun. And here I'm going to say from file, oops, from file, which is looking for the env. So I'm just going to give it the same env because I happen to know I have my key for my table. So in space and time, every object needs a public-private key pair. And this thing here, this space and time, this is kind of a convenience object that rolls a number of them together. But I can go to space and time, SXT, the object, and we can see there's actually a user object in there. And the user's got a user ID and it's got a public-private key pair. I'll print out the public key pair. Not going to print out the private key. But you know, you can see that this has a key pair. The table will also have a key pair. The key pair will be different for the table than the user. Sometimes people get that confused or they think my user's key will also be the key pair for the table. That's not the case. It needs its own. Let's do access type, and we're going to say sxt access table access dot. Let's make it a public read. That way anyone can read my table. Actually, probably it should be permission, but we're going to leave it public read anyway. And then if I say space and time parent, that's just to say that convenience object can be passed in. And then if you set up any logging, like you can do logging, you can add handlers, you can set up a lot of the environment through this XXT because it's kind of convenience object. It's convenience objects. The intention is to be convenient. You can just pack all of that into this object here with that one command. And I think that will do it. The other thing I need for my table is, of course, I need to be able to say create DDL. This is the DDL that is needed to create the table. So here we would do something like that works. And it's going okay. I don't think I need the ID. Let's just use the user ID. And I'm going to be picky here for a minute. I like it when we do it like this. And I don't really need all of this. We just need int. And, or actually, I'm going to make it a UUID. So I'm going to use that as varchar. We don't need to specify. And then we would want the campaign ID. And then we would want, yeah, the opt-in date. That sounds right. Although we want to get date. And we will need the primary key. I also want to have a reward token, which would be varchar, and a reward, reward amount, which would be a decimal. And that probably looks good. And I think that looks good. So this way I could have a user who decides they want to opt in for this campaign. There's an opt-in date. We probably ought to give an opt-out date so they can decide at what point they're done playing, they can escape. Reward token, reward amount, and let's say daily, just to make it specific. And with that little bit, the last thing we need here is a close paren, and then we're going to do a with statement. And this will actually get created for us, this with statement, but it's a placeholder for it. With that, the last thing we need is to add some permissions. My table dot. Now, to do permissions, we use biscuits. Biscuits, if you ever want to go read up on them, go to biscuitsec.org. Biscuit is an encoded token, looks something like this, and you can actually decode it and see the permissions inside of here. So maybe we'll try that here in just a second. For now, we're going to add a biscuit. You just give it a name, let's say admin, and then we have to give it some permissions. And I'll just say, actually, I think I can say sxt.grant. And then here's all the permissions you can grant. I'll just do all because this is my admin biscuit. And if usually you want a couple, you'd probably say my table dot add biscuit. And let's say this is for my AI agent. And we're going to say sxt.grant. Let's just let them select that they can't change anything. Or maybe they can change. Now let's just leave it at that. Actually, let's give them one more just because. We'll let them insert a row too. But you can't delete, you can't update. And we could do other things, by the way. We can say for a certain length of time or certain requirements for the user or the subscription ID. There's a lot of different variables, but we'll just leave it at that because this is starting to run a little long and I want to kind of wrap it up here. But I do want to come here and say print my table dot biscuits. And you can see what the different biscuits are. So the capability accessing this particular table, that's the private key for the table. I guess that's okay. It's I'm not really going to leave this table. So let's see the capability. Here's the biscuit token right here. Really what I wanted to do is copy that and come drop it in here. And you can see the different capabilities that we've assigned to our table. And with that, we're pretty much ready to say if my table dot exists, my table dot drop. drop it. And then either way, we're going to create it. And then I think, I guess we could insert a few rows. No, let's just create it for now. There we go. And now we should be able to say my table dot exists. Yes, it exists. And I'd be able to go see it in the interface that we had before. I could say sxt dot execute query, and just no, it's not at all what I wanted to do, but thanks for this. Nice try, Podium. I just wanted to say select star from this. That's fine. And it worked. It's just empty. Excuse me. Anyway, that's all the coding I think we need to do tonight. I wanted to point out that it's actually really straightforward to get started. That some of it, if you've worked with databases in the past, will feel really familiar. You just have to create table statements. There is a little bit of cryptography that's added. Actually, we could say, if I said, come here, if I say, oh, I killed it. Let's do that debug again. We do all of this. We get down here. I can say my table dot create DDL. Actually, let's do print. So it'll look nice. You'll notice when it says with statement, it has a with statement here, and it's going to do the public key for the table, and it's going to have access type public read, which is what I specified it up here. So it kind of puts together this and other things to make it work. To do tamper proof, what is it? It's immutable. Immutable is true. I think you also have to say tamper proof is true. And doing that will make it both tamper proof and immutable. Right now, tamper proof tables have to be immutable, which is why you have to do that. I will say that if you're going to do a ZK proven table, a tamper proof table, I would come back and do that last, because part of it being immutable means that you cannot delete it. You cannot drop the table. This command would fail. So if you have a schema that you really like and the name that you really like, and you create it and then you realize you forgot something, then sorry, you have to extend the model a different way, because a tamper-proof table is immutable, and immutable tables cannot be dropped, because if you could drop them, you could effectively mutate them. You could basically copy the data, drop it, recreate it the way you wanted it, reload the table with the same name. It would basically be mutable. So you cannot drop immutable tables. So what I do is when we're doing this, I will either leave this as not tamper-proof until the last moment when I need to actually go and test it as being tamper-proof. And then I'll do that so that I have time to make changes if I want. Or more often than not, I will also do a version. And so I can create multiple, if I version 2, version 3, but the name is preserved. Just little tips and tricks on immutability. All right, I think that's a good place to stop, and we'll jump back over. Whoops. Oh, all right, there we go. Thank you so much. Again, my name is Stephen Hilton uh, from Space and Time. Our webpage is down here on the bottom, as is my email and Telegram handle. If you'd like to get in touch, I would love to speak with you. I think people who are the audience for this presentation understand that this moment in time is pivotal. Never have human race seen a moment of transformation like this. So we are, in a very real sense, redefining what the future is. And I, for one, am fortunate. I feel fortunate and grateful for being able to be part of it. Uh, Thank you so much and happy building.